focusing on binomial distribution. We're going to be focusing on basic probability, and we're going to be focusing on a bit of set theory. We're going to try and leave the distribution tables and charts in the next week and the beginning of the third week, because that's tied up with statistics. Alright, so probability, the first part of probability is out on its own. It's your basic probability, it's your arrangements and combinations, it's your binomial distribution, it's your set theory such as your Venn diagrams. The second bit of probability is high straight statistics, and the two of them are jammed straight into each other, where you're using the log tables to get probability values, p values, r values, and so on. Is that right? So we're going to focus on the first bit first and leave the stuff that's tied in statistics to kind of the end of next week and the third week. So we look at the first question here, 2017 paper 2, question 1. We have Connor rings Kira's house. The probability that Kira answers the phone is 1 over 5. Connor rings Kira's house once every day for 7 consecutive days. Find the probability that she will answer the phone on the 2nd, the 4th, and the 6th days, but not on any of the other days. Do we know what we're going to do here? What do we have to create? Don't all shout at once. And you know what? This kind of question is in alignment anyway. If you were to look at that board, what would you start putting in alignment? The board on the left, sorry. When I start here and she will answer and she won't answer, success, failure. When you're given two outcomes, it's going to be along the lines of binomial distribution. Is that right? Lines of binomial distribution when you only have two outcomes. So your probability of success, probability of failure. So, probability of success, probability of failure. There's only two outcomes. She either answers the phone or she doesn't. Simple as that. Right, what is the probability she answers the phone? Sorry? Probability answer 1 over 5. What is the probability she doesn't answer the phone? 4 over 5, exactly. What's the big thing about probability? It can only range between 0 to 1, exactly. Probability can only go from 0 to 1. If you get an answer which is negative, can't exist. If you get an answer which is more than 1, can't exist. Right. On the first day, does she answer the phone or not? No, failure. On the second day, does she answer the phone or not? Yep, success. Third day? No, failure. Fourth day? Yes, success. Fifth day? Does she answer it on the fifth day? She doesn't, it's failure. And on the sixth day? Success. And on the seventh day? Failure. So, first day she answers it, first day she doesn't, second day she does, third day she doesn't, fourth day she does, fifth day she doesn't, sixth day she does, seventh day she doesn't. Right, the next important bit in probability, very, very top of your page, NB. The most important word in probability, do you have any idea? Probably two of the smallest words in English language. And an R. Who said? I got it. And an R. Two most important words in probability. And multiply by R, multiply or plus. And it literally is your understanding of the question when you get this way around. And multiply or plus. Two most important words in probability. Two very, very basic words. When Connor rings Kira's house, she doesn't answer on the first day, she does on the second, and so on and so on. Is it she answers on the first, or she answers on the second, or she doesn't answer on the third, or she does answer on the fourth, or she doesn't answer on the fifth, or is it she does answer on the first, she doesn't answer on the first, and she does answer on the second, and she doesn't answer on the third, and she does answer on the fourth? and or in the sequence. It's and. You wouldn't say, I didn't answer on the first, or I did answer on the second. You'd say, I didn't answer on the first, I did, and I did. It's and. So if it's and, it's multiply, exactly. Off you go, give the answer. What are we getting? I'm getting 3.2768 multiplied by 10 to the power negative 3. Make sure you know how to write it both ways. 10 to the power negative 3 means 0.0032768. We happy with that? We all know how I went from here to here, yeah? Do you know what 10 to the power negative 3 means? You have to add in 3 zeros. You have to move the decimal point forward 3 spaces. So I moved it forward. It was here. It goes 1, 2, 3. Move forward 3 spaces. That's what negative 3 means. If it's the other way around, then you move it back. Right. The second bit of the question. Find the probability that you will answer the phone for the 4th time on the 7th day. Now, the question with failure and success, when you get specifics, i.e. she will answer it for the 4th time on the 7th day, what are we thinking? Binomial, exactly that. Binomial. When you get specifics, it's binomial as success and failure. So, what do we want to happen? Chance on the 7th day, okay. I'll put you this way. What do we want to happen for the first 6 days? She answers it. Exactly, that's very, very important. On the first 6 days, she answers it 3 times. So on the first 6 days, she answers it 3 times. And then on the 7th, she answers it 4th. So I have my P, my Q, my N, and my R. So my formula is for binomial distribution, N over R times P to the power of R times Q to the power of N minus R. And it is in your logbook, page 20. Right. So, what are we going to do from here? What is what? Sorry, it's in your logbook, page 33. 33. That runs the binomial here. What is what? What's P, what's Q, what's N, what's R? Anyone know what P is? What does P stand for? Success. What's success? Probability of success in this? 1 over 5. Perfect. Right. What's Q? Failure. What's failure? 4 over 5. What's N? N is the number of trials, which is 6. And what's R? 3. The number of times she wants us to answer. So you literally put that straight in. 6, 3, what's the C. Very important. Not P, C. 6, choose 3. Not P, it's C. 6, choose 3 by 1 over 5 to the power of 3 by 4 over 5 to the power of 6 minus 3. Right, get me an answer for that then. What do we get, guys? 0.08192. Right. What is that? Explain to me what that figure is. No, it's not. Not yet. Brilliant. It's the probability that she will answer it 3 times in the first 6 days. I wasn't asked that though. I was asked you'll answer for the 4th time in the 7th day. What to do? Brilliant. Multiply it by 1 over 5. Because on the following day we want her to answer the phone. We multiply it by 1 over 5 and what do we get? We get 0.003784. And that's your answer. My recommendation is give it in decimal form. Alright, so probably give it in decimal form instead of giving a big fraction. Is that right? 2 seconds now, my calculator could be in the wrong mode. 0.08192 multiplied by, oh sorry, 0.16384, is it? Yeah, apologies, calculator was in the wrong mode. That happens, 0.01634. Right, bottom one. Connor rings her house once every day for n days. Right in terms of the probability that he will answer the phone at least once. Anyone know what the important phrase there is or word? At least once. Brilliant. What does at least once mean? It's formula we need to know. It's not in the law book. 1 minus the probability of none. 1 minus the probability of none. Right. I won't explain more. Have a go and see can you get that little phrase right there. See if you can put that into figures for me. Right, any idea? 1 minus none, 4 over 5 to the power of n. Failure is 4 over 5. How many times? We don't know, which is n. Right. Part D, all in line with it. Find the minimum value for n for which the probability that Kira will answer the phone at least once is greater than 99%. Logs. How are we going to create logs? Help me create the expression at the beginning. Zero point 99. Exactly. 1 minus 4 over 5 to the power of n is greater than 0.99. Right, off you go. Algebra revision. Get me in. Algebra, so I get n on its own. So move figures around so we get n on its own. Anyone remember that? And I told you what happens to the log from using this. Not necessarily sign chain, but please be careful. Do you remember the rule I told you? We can't use that. We can't use the rule we always go for logs bringing it down. We can't use that. In this one, I don't think it's going to affect it, but it's good practice anyway to remember it. That we can't use the log on the one top right corner. Why can't we use it with this? Because we don't know if that's positive or negative. Now, it's probability, and it's a number of times we know it is positive. But it's a good thing to remember there. Be careful using that rule with its inequality signs, because it could flip the sign. Is that alright? Very, very important. In this case, we know n is positive, and we know n is a number because it has to be a certain amount of times. We don't link to a negative number of times. So it's not going to affect it in this situation. We have to be very careful when we're normally dealing with logs that when it's that, we don't use the log rule in the top right corner, one that flips the indices the logs, or log rule. Alright, we have to make sure that we use the logs of AC, bring the n to the front, and then divide across by the O. Is that okay? I'll show you now in a minute. Right. So, minus 4 over 5 to the power of n is greater than 0.99 minus 1. Minus 4 over 5 to the power of n is greater than 0.99 minus 1, which is negative 0.01. Cancel your minuses. 4 over 5 to the power of n is greater than 0.01. Now, as I said, normally we could use our log rule. The a to the power of x is equal to y can be written as the log of y to the base a is equal to x. Normally you can use that, but he affects it. He gets affected if you're bringing over the n and it's negative. So what you would have to do here, just to be sure, normally, you just have to say log to the base e of 4 over 5 to the power of n, let's see, of log to the base e of 0.01. Log to the base e, ln. Is that right? So that'd be n times the ln of 4 over 5 is greater than the ln of 0.01. Of course that happens now, 2 seconds. The ln of 4 over 5 to the power, bring her into the front, n times the ln of 4 over 5 greater than ln of 0.01. N is greater than the ln of 0.01 divided by the ln of 4 over 5. N is n is equal to 20.63, n is equal to 21. Now, you wouldn't have been docked for using that rule up here because they would have said you understood that n was a positive number because it's the number of times you ring someone. But just in future, just be wary of that. Is that right? Just something we looked at the last few weeks. You introduce ln when it's an inequality sign instead of using the rule. Right, let's jump on. Yeah, have a look at this one. In Galway, rain falls in the morning on 1/3 of the school days of the year. When it is raining, I'll bring that up to the side actually so you can look at the whole thing. In Galway, rain falls in the morning on 1/3 of school days of the year. When it is raining, the probability of heavy traffic is a half. When it is not raining, the probability of heavy traffic is a quarter. When it is raining and there's heavy traffic, the probability of being late is a half. When it is not raining and there's no heavy traffic, yada yada, 1/8. In any other situation, it's 1/5. And so on and so on. Right. Have a whack up. You can fill in as many of those figures as you can, possibly. Anyone who's unsure of any letters, give me a shout. This is R, no R. This is T, no T. And this is L, no L. So it's R's in the first one, T's in the second one. See how many of these you can get. Any figures are unsure, give me a shout. the most important thing that I tell you about probability has to be between 0 and 1. Don't forget that. Probability must be between 0 and 1. I.e., the boxes on the right must must all add up to 1. That's how you know you're right. Beautiful thing about this question is you know you're fairly right with all the boxes on the right add up to 1. This question is a lot easier than you think it is. You got all your boxes filled in and then fill in the last ones. You can make your decision once again with your 2 words. Is it and or? And. Exactly. You have to make your decision in. To get your final boxes, it's just all your. It's the tree diagram. Get your all in the tree diagram, get your last boxes along your tree. Any questions, give me a shout. Get 1 at the end, you're fairly right. You can earn 30 seconds there just to finish that off. Have a question, please? Give me a shout. Right, let's look. So, I'll fill it in over here. In Galway, it rains in the morning on 1/3 of the school days in the year. When it is raining, the probability of heavy traffic is a half. So the probability of heavy traffic is a half. And so on. So, random school day in Galway. The probability of rain is 1/3. What's the probability of no rain? Oops. Back. Probability of no rain is Stop doing that. That's very nice. 2 seconds, sorry. Absolute Wally. No, it's not going to work right. Sorry guys, 2 seconds. This yoke's having a fit. Right. Well, I'm trying to figure out what's working on that. 2 seconds. What the hell's going on here? I'll come back and jump to that in a second. Have a go at this. Please. Figure out why this isn't right.
One more minute, guys. I'm just getting this fixed up and reboot it. Hey lads, my pen tablet's after breaking for some reason, which is perfect because I just need it for everything. Right. So I'm not going to be able to write them, leading you off. That's right board. So, perfect.
When rain, probability of rain is 1/3, what can we put in here? 2/3, exactly. Put 2/3 inside there. So, probability of rain is 1/3, no rain, 2/3. So, out of that then, the probability that there's heavy traffic is a half. Probability there's no heavy traffic then is a half. If there is rain, if there's rain and there's no traffic, so if there is rain and there is no traffic down here, up here, that brings you up to traffic. And down here then is no traffic. Yeah. Out of no traffic then, it's going to be, let's do it here. This is 1/5, and down here then is going to be 4/5. So a half, 1/5, and 4/5. Over here we said was a half. Down here we have 2/3. This is 1/4 down here is 3/4. If this is 1/8, this is 7/8. So the only ones we haven't filled in so far is what is the probability when there's no rain and we have traffic? What do we fill in? 1/5. In any other situation, probability of being late for school, i.e. in any other situation, probability of being late is 1/5, probability of not being late, 4/5. So we have 1/3 by a half, 3/2 is 6/2 is 12. 1/12. 1/12, what do we have down here then? 1/12. 1/12 is up. And then we have, I can't hear you guys, I'm half deaf. Adam? You didn't fill them in, no? Alright, so you multiply across. 1/3 by a half is 1/12. Here then we have 1/3 by a half by 1/3 multiplied by 1/2 multiplied by 1/2 obviously is 1/12 and 1/12. We then have 1/3 by a half by 1/5. We're getting 1/30. It's 1/3 by a half by 4/5. We're getting 2/15. We are then getting 1/3 by a quarter by a fifth, is it? 1/3 by a quarter by a fifth. We're getting 1/60. We're getting 1/3 by a quarter by 4/5. We're getting 1/15. We're getting 1/3 by, we're down to these last two, we're getting 1/3 by 3/4. Sorry, here, say 2/3 by, that affects the answer then. Yeah. So that's 2/3 by a quarter by 1/5 and so on. Sorry. 2/3 then by, what's down here? 3/4 by 1/8, which is 1/16, and then it's 2/3 by 3/4 by 7/8, which is 7/16. How do we know we're right? You add them all up and you get 1. Exactly. Right. So, moving down then, we answer the following question. On a random day in Galway, find the probability of being late for school. How are we going to find the probability of being late for school? Sorry? How many probabilities have we're late? We have 4. 1. You have this one here. You have this one here. That you're late. This one here you're late, and that one there you're late. 4 times you're late. So, are you late, late, and late? Or are we late, or late, or late? Adding or multiplying? Add. Why are we adding? You can't be late and late and late in the same situation. You can either be late because of this, late because of this, or late because of this. It's or. That's why and or is very important to make our decision. So it's add. What was my probability up here again? 1/8. What's probability here? 1/8. This one down here. Number 9 and E, lads. One over 12. 1/12. 1/30. 1/2/15. Then 1/30. Then 2/15. Then 1/60. 16 and 7/16. So, probability of being late is 1/12 plus 1/30 plus 1/30 plus 1/16. What do we get? 1/12 plus 1/30 plus 1/16. 12. And we get an answer of 17/80. So probability of being late then is 17/80. Right. Bottom bit. On a random school day, find the probability that it rained in the morning given that you were late for school. Anyone know what the important word is there? Adam? Sorry, Gavin. Which Given. Why is given in hard work? Exactly, it relies on something and then happen. So, first thing you have to think, given is important. Now, when it comes to given, you have independent and you have dependent. You have independent and you have dependent. Are these events independent or are they dependent? On a random school day in Galway, find the probability that it rained in the morning given you were late for school. Does being late for school affect rain in this situation? It does. It told us that we were late because it rained, or we weren't late because there was no rain. It does affect it. It's very important. So, when it's independent of each other, probability of A given B has happened is just the probability of A because B doesn't affect it. Does anyone know the formula when they're dependent? What is the probability of A given B when they're dependent? Probability of A intersection B over the probability of B. Exactly. Right. What is A? What is B? A is what? Find the question asks us. Find the probability that it rained in the morning given that you were late. So rain given late. So this is rain. That's being late. So probability of A is rain. Probability of being late. Sorry, probability of B is being late. Right, off you go. Try to get those two figures. You want to get the probability of rain given you were late. You can, yeah. Right, we got an answer? So, what is the probability that that it rained and he was late? How do we get that? R intersection L. So A intersection B, or in this case, R intersection L. What is the probability of R intersection L? It rained, so it must be this one up here. He was late on 2 occasions here and here. So you say R intersection L or R intersection L is equal to 1 over 12 plus 1 over 30. 1 over 12 plus 1 over 30, 7 over 16, 16, half there. probability he was late? What's the probability he would be late? 17 over 8, exactly. 17 over 8. And there's your answer there. So you have 7 over 16 divided by 17 over 80. And we're getting 0.5490. Oh, she's having a mirror for me today. Right. So 2016 paper 2 question 5. I had you start this. In an archery competition, the team consisting of John, David and Mike will win first prize if at least 2 of them hit the bullseye. So we get first prize if at least 2 of them hit the bullseye, that John, David and Mike will hit the bullseye. On their last stars, 1 over 5, 1 over 6, and 1 over 4 respectively. Complete the table below to show all the way they could win first prize. So, J, D, N, draw our table, weigh 1, 2, 3, 4. First way is John and David hitting Mike misses. Next one we could go with is John and Mike hitting David misses. Next one we could go with David hits it and Mike hits it. Last one we go with all 3 hit. You happy with that? Right. Hint or otherwise find the probability they will win the competition. Once again, and or. And. How do I get the probability for this? What's the probability, first of all, that John hits it? 1 over 5. David? And Mike? 1 over 4. Right, weigh 1. So, that's 1/5 multiplied by 1/6, and you get 1 over 1/30. We have 1/5 by 1 over 4 is 1 over. Sorry, yeah, it's 1 over 5 by 1 over 6 by 3 over 4. Apologies. Because he missed over here, so that's 3 over 4. 1/6, 1/5. 1 over 5 multiplied by 1 over 6 multiplied by 3 over 4 is 1 over 40. Down here we have 1 over 5. What's the probability? David misses. 5 over 6. Mike hits it then is 1 over 4. So that's 1 over 5 by 1 over 4 by 5 over 6, which is 1 over 24. Here is 4 over 5 by 1 over 6 by 1 over 4. We're getting 1 over 30. And the last way is 1/5 by 1/6 by 1 over 4. So that's 1/5 by 1/6 by 1 over 4. 1/5 by 1/6 by 1 over 4, and it's 1 over 120. Right. How would I figure out the probability they'll win the competition? Why am I adding? It's or, exactly. And is the ball hitting it, or is you can win it way 1, or way 2, or way 3, or way 4. So you add it. Plus, plus, plus. 1 over 40 plus 1 over 24 plus 1 over 30 plus 1 over 120. And we're getting 13 over 120. Happy with that? Right, next part of the question. Two events A and B are represented in the diagram. Probability of A intersection B is equal to 0.1. Probability of B less A is equal to 0.3. Probability of A less B is equal to X. Write PA in terms of X and hence order is find the value of X for which the events A and B are independent. So, independent. What's the problem here? Drawn is a bit unfair. It's independent and dependent. So technically independent is that. Where the probability is, does anyone know what happens when they're combined? What probability of A intersection B is? The formula. Probability of A multiplied by the probability of B by, they're dependent on each other. Gotta take away that. The overlap exactly. Minus the probability. Gotta take away the bit of it. Over here, it's simply probability of A multiplied probability of B. Alright? Because they're independent of each other. Ready? See if you can work it out from there. We have liftoff. Drive me insane. Short temper. Alright, Adam. Right, so independent, don't forget probability of A intersection B, probability of A multiplied by the probability of B. Anyone know what the probability of A is here? I'm so dead, you know it. 0.1 plus X. What is the probability of B? Why is it 0.1 plus X? Because it's X and the 0.1 is included. What is the probability of B? 0.4. Why is it 0.4? Because it's 0.1 and 0.3. So, the probability of A is equal to what then? I'll do a bit of algebra. Probability of A intersection B divided by the probability of B. The probability of A intersection B is equal to the probability of A multiplied by the probability of B divided across by probability of B. You got to get probability of A on its own. It's a bit of algebra in there. So probability of A is equal to probability of A intersection B. Do we know it? 0.1. Where am I getting that from? Up here. Probability of B is 0.4. And it's equal to the probability of A. What's the probability of A? Sorry? 0.1 plus x, which we got from up there. 0.1 divided by 0.4. 0.25 is equal to 0.1 plus x. 0.25 minus 0.1 is equal to x, which is 0.15. And that's your answer. That okay? The only way you get better at these set theory questions is, I'm going to put them up, is you have to practice them, because there's so many little formulas that you have to know, and you have to know what happens when it's independent, what happens when it's dependent. The only way you're going to get better at these is, I have a load of set theory questions on them homework sheet, you just have to practice them. Is that alright? Because very few come up on the exam papers, and there's so many different types that you have to practice the homework questions to be ready in case one of those come up. Is that fair enough? Right, next little question we're going to look at. I'm going to do this. Right, Examcraft 3, 2018, paper 2, question 3. What I'm also going to start doing as well is, at this stage and point, you need to be doing half an exam paper a week, i.e. there is 9 questions on a paper. So you need to be breaking up into 6 short questions a week and 3 long questions the following week, minimum. After Easter and during Easter, it needs to be a paper a week. So obviously there's no point really doing the same papers over and over again, because you know them. So I'm going to start putting up as well the DEB papers. So 6 short questions a week. The following week will be 6 long questions. Sorry, the 3 long questions, 6 short questions, 3 long questions, and so on with the marking schemes. You need to be doing them a week at the moment, minimum. Is that alright? You need to be hitting these 6 short questions a week and then 3 long questions the following week. On top of what else you're doing. Right. How many different teams of 15 players? There's no point doing the same exam paper questions. You're better off doing pre's and then sample papers are crap. So you're better off doing pre's instead of sample papers. How many different teams of 15 players can be chosen from a panel of 20 if the captain must be included? So, permutations or combinations? Combination, chosen. Chosen throws it out to straight away. You see chosen, it's combinations. It doesn't make a difference. Anyone know why it's combinations anyway? It's 22-15, but it doesn't make a difference what order there. Anyone know when permutations comes in? For example, you're given the word schoolyard. And how many different ways can S come first when A jump and A comes next and then Y? When you're asked to put certain letters in certain places, that's when you have to start thinking permutations. When they ask you to start selecting teams from different sets of pairs, it's combinations. Is that fair enough? Alright, so you're asked to put things in definite order, permutation. When it can be any order at all, combination. Very important. Right. How many different players of 15 can be chosen from panel 20? You should be able to do that. Off you go. Right, let's look. 20 players from panel, 15 players from a panel of 20. From 20, choose 15. So that's 20, shift NCR, 15, and we should be getting 15, 504, 15,504. Do we all know where the NCR button is on our calculator? On the black ones, I haven't a clue. Oh, sorry, the captain must be included. Apologies. 20, choose 14, you're right. I missed that little word. Captain must be included. So, from 19, choose 14. From 19, choose 14. I didn't see the line. From 19, shift NCR, choose 14, and it's 11,628. Right, 2 players refuse to play on the same team. What are we going to do? Two lads are boxing it after they want to play on the same team. What am I going to do? Okay, the even choose. Sorry, you choose. Or leave them out. Leave them out completely. We're not leaving complete. No, she was leaving completely out. She only picked 18. She was 13. How many players are we? We have 20 players. How many do you want to choose? 15. This is very like a probability question. What's the probability of the formula for the probability of at least once is 1 minus none. So if you think about it, 20 ways to choose 15 players. And then we also have to think about the 18 players, 13. Because they're the teams that don't include them. Exactly. So you have 20 players, choose 15, which is 15,504. Then we take into the total number of groups without them. Which is 18 players, choose 30. Then that is 15,504. Then the groups without them is 8,568, which is 15,504 minus 8,568, which is 6,936. Is that okay? Right, the next bit of the question. A and B are two events such probability of A is equal to 0.35, the probability of B is equal to 0.46, and the probability of A and B is equal to 0.61. Right, give me the probability of that. See who was paying attention the last hour. Off you go. Done this today. Twice. I used the wrong symbol down here. We presume dependency if they don't tell us it's independent, by the way. We presume dependency if they don't tell us it's independent. We enter an exam, a real one, that's it. And free. So, first things first, Abby, picking on you. Do you remember the formula for this? Done it twice today, so much you were paying attention. Man, I've got to pay attention. Gav, what's my formula? Good lad. Probability of A intersection B over. Good lad. Right. We have him. Probability of B. We don't have him. Anyone, any idea I'm going to get probability of A intersection B? Probability of A by? Minus probability of A union B. My fault. I gave you the wrong little bit at the beginning, just down there. Probability of A, I put in intersection twice and then put in union. Probability of A intersection B is equal to probability of A, which is 0.35, probability of B, which is 0.46, minus the probability of 0.61. If they give you that as well, there's no reason for them to give it to you unless it's dependent. If it's independent, it doesn't affect it. So if they give you that, you have to use it. Anyone know what it is? Sorry, A plus. Jesus, Paddy, plus. .35 plus 0.46 minus 0.61. 0.2. So, back to my formula then. Probability of A intersection B is 0.2 divided by 0.46. And if I give you the right formulas. What are we getting? 0.435. Correct that formula instead. Right, 10 minutes left. Off we go. Once again, see who's paying attention to me today. Player has 3 over 5 chances to score a penalty in the match. During the season, he takes a total of 12 penalties. Find the probability he misses the first 2, scores the rest. Give your answer correct to 4 significant figures. Find the probability he scores a 6th penalty on his last attempt. Give your answer correct to 3 decimal places.
Trying to get more to this. There's 2 questions.
Give me 6 minutes. He's done it all today. Remember what I did with the S and F's at the very beginning? F, 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 S, 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 S. Two more minutes, please.
Alright, boys and girls, let's have a look at it.
So, player has a 3 over 5 chance of scoring a penalty in a match during the season. He takes a total of 12 penalties. Find the probability that he misses the first 2 and he scores the rest. 2 outcomes. What am I thinking? Bernoulli, exactly. So, what is the probability of failure? 2 over 5. What's the probability of success? 3 over 5. He misses the first 2 and scores the rest. Fails, fails, and then he takes 12. Scores, 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 scores. Fails with the first 2. Scores with the next 10. Be happy with that? So that's fails, which is 2 over 5. He fails and fails. And, exactly. Multiplied by 2 over 5, multiplied by 3 over 5, by 3 over 5, by 3 over 5, which is 3 over 5 to the power of 10. So that's 2 over 5, multiplied by 3 over 5 to the power of 10. You could also do 2 over 5 by 2 over. You could do it out the long way, but that's just speeding things up a bit. 2 over 5 to be squared multiplied by 3 over 5 to the power of 10. What are we getting? (9.6745) multiplied by 10 to the power negative 4. Give it in decimal form, 0.00096754. Is that right? 1, 2, 3, 4. It is correct. 4 significant figures. And you know the difference between 4 decimal places and 4 significant figures? Very important. What's the difference? These aren't significant. It's your first number. That's significant. Very important. 4 decimal places and 4 significant figures, not the same thing. I.e., 4 decimal places here would be 0.000. That's a 6, so that makes that 10. That is 4 decimal places. 4 significant figures is 0.000967. That's a 4, so that stays 5. They are 4 significant figures. Very important. Is that okay? These aren't considered significant. This is decimal places. This is significant figures. Right. Last little bit for today. He scores his 6th penalty on his last attempt. Bernoulli. N over R. P to the power of R. Q to the power of N minus R. What's N? 12. R. 6. P. Probability of success. 3 over 5. Q. Probability of failure. So that's 12. Choose 6. P, which is 3 over 5, times R, which is 6, by Q, which is 2 over 5 to the power of 12 minus 6, which is 6. Which is 12, shift, NCR, choose 6, multiplied by 3 over 5 to the power of 6, multiplied by 2 over 5 to the power of 6. 0.1765. 3 decimal places, 0.177. Right. We hit Bernoulli a good bit. We hit basic probability a good bit. We hit a nice bit of set theory. It's going to be more permutations, combinations, set theory, and we're going to leave the probability distribution in the logbook till last week. Is that right? Probability and statistics takes 6 full weeks to get through. Paper 2 is literally trigonometry is the biggest part, then probability and statistics, and then you're going to have a tiny bit of area and volume and trigonometry in one question, and then you're going to have either 2 questions of geometry, the line and circle, or else 1 question of geometry, line and circle. It's as simple as that. So you nail trigonometry, probability and statistics for paper 2, you pass it, and you do very well in it. You have to nail the other little bits to do if you want to get your H1, H2. It's like in paper 1, you get your functions, your differentiation, and your algebra right. You're passing that paper and you're doing well in it. The 2 papers are broken up into major sections. Trigonometry, probability, statistics, big parts of paper 2. Algebra, differentiation, and functions, major part of paper 1. If you want to get your H1, H2, H3, you've got to nail all the other bits. Solid. Is that fair enough? I'll see you next week for another bit of probability. And apologies about the pen tablet having a bit of a fit. And me in turn having a bit of a fit.